All right. Well, it seems like everybody's lunch is probably over right now, so may as well start and get going. Hi, my name is Kevin Kane. I'm a program manager for demographics and growth vision at the Southern California Association of Governments, or SCAG, which you probably already know. And welcome to Toolbox Tuesday, our series of information and learning passed off to everybody in the region and beyond. This is kind of a special, a little bit more of a boot camp kind of edition of Toolbox Tuesday, and happy to be here and be able to teach everybody here how to use R, the statistical programming language that has really become kind of a really useful open source and free tool for planners, policymakers, data scientists of all ilk. It's extensionable, it's open source and free, it's replicable. It can be a little bit finicky at times, but I've designed this 3-hour boot camp in a way that hopefully will take you from, say, an intermediate Excel user in data to somebody who is able to, for a project of your choosing, use R. And the focus is really going to be toward the U.S. Census Bureau's API, or Application Programming Interface. That's really the goal here. We're going to get through all of the nuts and bolts, so at the very end you can actually use the Census API. And I'll kind of show you a little bit about what that is. But basically, any census or American Community Survey data at any spatial scale that is available can be called, downloaded, processed, and even mapped through the R programming language. So that's really the objective today. I find this totally invaluable for my work, looking at the 197 cities, 11,000 census tracts in 6 counties of Southern California. And I'm sure that's, there are just so many application areas. I'm not going to waste time going over all of the application areas because you know these a little bit better. But I am going to introduce our two co-instructors here, and I'll turn it over to them to just say a quick hello. First, Dr. John Cho, also at SCAG.
Hi, my name is John Cho. As Kevin mentioned, I'm very glad to work with Kevin and help for this Toolbox Tuesday.
Thanks, John. John and I both teach a course called Big Data for Urban Planning and Development that uses R and a similar workflow over at USC in their Executive Masters in Urban Planning department. And also here is Tom Vo from SCAG, Program Manager as well.
Thank you, Kevin. Good afternoon. My name is Tom Vo. I'm the program manager for the local information services team. And the Toolbox Tuesday is actually one of the projects within the program. So I'm happy to be here to assist Kevin and John with this really successful and innovative session today. And quite frankly, I went over the code myself before this, and it's actually very intuitive, and you can use the script for a lot of the programs and data analysis, and also connecting that with ArcGIS. If you are a big GIS spatial nerd like myself, I find it really, really interesting.
So we've got 104 GIS or spatial nerds here already. And I'm very thankful to have Tom and John here, because we're going to spend, depending on time, 2 or 3 portions in a breakout session where you actually will have a little bit more opportunity to maybe ask a question or troubleshoot an issue. But I would encourage you also to put any questions or issues or problems in the chat. Either to everybody or to John Cho or Tom Vo, who are you may see them listed as co-hosts here, but they are your question answers and teaching assistants to a degree. So I encourage you to put questions into them, and they'll stop me if it's something that's that could benefit the wider group. One other point, if you are interested in ASL, American Sign Language Interpretation Services, you see Jamie here, and her colleagues will rotate in and out. But because we are having breakout rooms, if you wouldn't mind renaming yourself with a small asterisk next to your name, then we'll know to put you in a breakout room that has the ASL interpretation. And yes, this will be recorded so you can go to it afterwards. My strong recommendation right now, and I think we put this in the information sent before, is to try to do a dual screen setup if you can right now, where you can both watch but also follow along in our studio. That's going to be the best use of your time. You probably are. It's a little bit less useful if you spend 3 hours listening to somebody yak. Because that you can do over a video at double speed. But if you're actually following along, you'll be able to see what's going on, and you'll have a couple of breakout sessions and the chat for a little bit of support. Use some of the reactions. Those are helpful too. I keep an eye on that. It helps kind of keep me at the right pace. I'll be sprinkling in a bunch of helpful hints along the way, and we've got about eight kind of mini sections. So we'll do a break right about in the middle too. One note too, as I open up the script file, if you are falling a little bit behind, it's designed so that you can just run a big block of code and catch up, and then you can go back to that later for a little bit more detail. No, that's not the Goodyear blimp. This is a Douglas DC-3 over downtown LA that I had the pleasure of being able to ride in some years back. Mike, thank you for that question. All right, so let's see if I have anything else. All right, so I'm going to share my screen now, and I like to start from nothing because that's kind of what coding is like to a degree. And actually, sorry, let me change that. Before I get into it, Edward, I think you've got a quick poll for everyone just to kind of level set, just to gauge where everybody's at. Okay, well, that's a pretty good response rate right now. So let's see, we've got about 100. So out of roughly 104 have used R extensively. 26 have used R somewhat. Okay, so I'll make sure not to be, so we can get to some of the more advanced materials. 40 have used another programming language. I've got to imagine things maybe SAS, Stata, Python. We can get into it. Type it in the chat if you'd like to kind of advertise your favorite. But about a quarter with no coding experience. Okay, all right, so that helps me out. Thank you. All right. So now I'm going to get into it and just start from nothing here, and go to the SCAG Toolbox Tuesday site, where all of the links had been placed. This is the same, that's in your email. I'm going to assume that folks have installed R and RStudio on their computer. There is a handy guide here put together by somebody at the U.S. Geological Survey about installing R and RStudio. It's pretty helpful because I didn't have to build one of these myself because it's pretty much all the same. Really what you need two things. R is the actual programming language itself, but its graphical user interface really leaves a lot to be desired. There is another open source program called RStudio, which is just a heck of a lot more user friendly, and it color codes your code and things like that. So that's a really good feature. One of the nice things about R is it's very extensionable. There are thousands of packages, and you can even build your own package to do something specific. So while this suggests a handful of commonly used packages, but that's not really necessary. So I'm going to go back to the site here and click where I put all of the course materials, and give me a thumbs up or something like that if you use GitHub. I don't use it all that often, to be perfectly honest, but it is a really it is at the very least I found it kind of a helpful lightweight tool for doing some file sharing. So that's what I've got it here for. This is all the course materials here. And in order to download these, I would recommend downloading these to a known place on your computer. Hit the code button right here at the green and then download a zip file of these dozen or so files. I'm working on a PC here, so again, apologies to the Mac folks in the audience. There might be a little bit of translation required on your end. But what I would recommend doing is find something in your, find a location on your computer that you know where it is. And that it's titled something that's intuitive. What I typically do, I've been using Dropbox, but I have it set up here. So I'm going to make a folder that I know the file path of under our boot camp. I'll do a new one and I'll call it 2022 because it's been a few years since I did that. And if Tom or John, if you could put the link in the chat for me, that would be really helpful for Rafi's question. Again, it's a GitHub link. I encourage you to just hit the green code button and download the zip file, which has all dozen or so files here. So what I would do then is now that I have a folder here, it's called 2022. I'm going to take all of the pieces here and copy them over and put them just somewhere on my computer where I'll be able to find them again. I've found, and I'm sure a lot of folks kind of, if they're a little bit more technically oriented, have found the proliferation of things like Teams and OneDrive and these other features a little bit lacking in terms of file management. Sometimes the old file tree where you have a C drive / documents, et cetera, is helpful. So let's take a look here at what we've got. A lot of this is sample data. So I have included a data set from the American Community Survey, from the BLS or Bureau of Labor Statistics, from the California Department of Finance or DOF, and also here from the OECD, Organization of Economic Cooperation and Development, for some international data, and also some metadata for the OECD because there's not a great link for that. I also have included for you a short reference card for R, which I find helpful every once in a while. It's really easy to just do a Control F and search for a command or something. I just searched for read.csv, which is how you read in a CSV file. So that's something that's really helpful too. There are so many resources if you are to Google it or whatever, but sometimes it's nice to have something you're a little bit more familiar with. Most of what we'll be dealing with is this file here, rbootcamp_2022. This is a .r file extension, which is used for R code, but it's really just a text file. It's really just 400 some lines of text if you've opened it already. And the last thing that I've got here that I want to show you is this is a little bit biased, but because they're, what I've found in my work kind of doing demographic forecasting and a variety of regional planning tasks is that, the American Community Survey data is really the best there is for so many things. And it's so rich. Obviously, people like big data and faster data, but so many of the core things that we deal with in our work it really just goes back to the ACS. So what I've done here is I've picked the 100 variables from the ACS that I use most commonly. You'll see their variable code, a description, and then I've named it with an abbreviation. And in the code file we have, it will correspond to this. So you can see some basic demographics, information on race, ethnicity, mobility, vehicle ownership, work commutes, education, income, and housing to round out my, I guess, 125 or so favorite data points. So I recommend this as kind of a starting point. I think it probably, I would imagine, touches a lot of the work that we do kind of as, geared toward planners in Southern California. So that's the data that we have here. And the next thing I'm going to do is open up RStudio. And I'm going to open up RStudio directly. It's just an application here. It probably shouldn't matter too much which version you have. I imagine most folks have a newer version. And this is the general layout here, is that on the left side, you have what's called the console. You'll see this little arrow, which is a chevron. That's where you type code. And it's typically you see 4 panes. I like to have the console here. There is another pane here that gives you some of the history and some of the environment paths if you use those. I don't use it much. And once you open a script file like the rbootcamp 2022 that I showed you, that's probably going to pop up to the right. So why don't we go ahead and do that and open up a script file here. So in the RStudio GUI or graphical user interface, just hit the file and hit open and navigate to wherever you just saved that whole bunch of files. Again, I keep it in a Dropbox, which is linked over here. And I saved it under R Bootcamp 2022. And here's my .r file, rbootcamp_2022. So that's going to open it here, and let me just rejigger a little bit of my Zoom stuff. You'll see it come up on usually the top right. If you want to reorient how these are so that it matches the way I have it, and to kind of keep the cognitive dissonance to a minimum, you would go to View, the View drop-down menu, and under Panes, there is an option here at the bottom called Pane Layout. So if you do Pane Layout, you'll be able to change what each of these 4 quadrants are. I tend to like having the console, which is where you type in commands, on the top left, and the source or source code, where your code file is, on the top right. Once we get into some plotting later, those will typically, that goes to this bottom right here. So console, source, environment, history, etc., files, plots, etc., is how I have my setup here. So I'm going to hit OK. And then basically what we'll do is really just run through this, which is this R script, which is a full course. I've put a few additional resources here. You've already been to rproject.org, which is the R main site. You've already probably downloaded RStudio here. There is another site that I would recommend for some statistics and other types of functions in R that I find really helpful if you're curious on how to put a graph together that you want to look a particular way, or maybe how to do some basic statistical tests or regression analyses. I would consider starting here at this statmethods.net site. So I'll try to orient this toward maybe some, in general, somebody who has like a little bit of experience coding in some language, but try to make it as good as possible for all levels. So if you're not familiar with a command line interface, this could be a little bit tricky. But the bottom line is we're running single lines of code or multiple lines of code at a time. And you run them in the left side, the console here, where you get this blinking chevron. And they come from here, or you can just type them in. So, you know, the most straightforward way to run code is just to type it in. So there's a command called print. And if I want to print a string of letters, I just put it in quotes. And one thing that's kind of fun or common to do is to do a print command for hello world when you start programming in a new language. So that's just print hello. So, I mean, this does like nothing, but it's an example of an easy command. So you can always type in, if I just type in some gibberish, I'll usually get a nasty red error message like this. Another way to run a line of code is to have your cursor on that line, anywhere on that line. And then to the top right here, you'll see this button called run. So if your cursor is hovering over run, if your cursor is on a line and you hit this run button, it's going to run that line. So I had the cursor on line 21 for print hello world, and it did it. Same thing happens if you highlight it. You can actually highlight multiple pieces of code at the same time and hit run, and it will run all of the ones that are highlighted. So that's an easy way to use the mouse for it. What I do probably most of the time is Control R. I know some configurations have Control Enter. So if your cursor is here and I hit Control R, as I just did, it's going to run line 21. So that's what I typically do. I've noticed on some computers, maybe it's a Mac thing, maybe it's just how I have had mine configured for years. It's Control Enter or something else. But regardless, you have 3 options, and you can always copy and paste something into here, into the console as well, if you like. So R is a little bit finicky. Always check your syntax. Make sure it is case sensitive. Make sure that you close your parentheses. Make sure that you close your quotes, things like that. From what I understand, that's one of the digs at R, is that it's a little bit finicky with some of this. I strongly recommend, especially when starting off, to stick with CSV or comma separated values files. These are just pretty, these are just really straightforward. You don't have to mess with Excel sheets and formatting and things like that. So the first command that I'll really teach you here is read.csv. If you ever need help with the command, though, you can always just use help and then the name of the command, and it will pop up in the bottom right here. If I were to, move my Zoom things out of the way, you'll get this help file here. So if you want help read or question mark read.csv, that will give you the info on the read.csv command or family of commands. A little bit wonky, not super intuitive or user friendly, but that's a resort. Google is also quite good, but you can get into a bit of a wormhole because there are so many applications and use cases, they might not really fit yours. So reading in some data, the easy way to do it is to use the read CSV command and then this little structure here called file choose. What this will do is it will open up, and I can show you, I'll run this line here. If you run this line of code, it's going to actually open up this handy little file editor or file selector, and you can navigate to wherever you saved your material. Again, I saved it under Dropbox here, 2022. And let's open up this OECD data. So if you do file.choose, navigate to where you saved all your data, open the one that's called OECD. You'll see it's a Microsoft Excel comma separated values file. And where did it go? Oh, that's right. When you don't get an error message, that means it's successful. So if you get a fresh line of code, that means it's taken whatever you've given it. And what we did here is actually read a file in, and we've called it data. DATA is the name of the object, so to speak. So if we type it in, we can actually see what all of the data are. It's not a terribly good way to interact with your data, but that at least proves that it's there. What I would recommend, though, instead of using this file.choose structure here, is actually to set a working directory, is what it's called. So we typically work in a folder, for a project. So we're making graphs, we're outputting things, we're reading in data, we're exporting new data. It's very convenient to set a working directory. You can see what your current working directory is if you run this line here, 33. So again, highlight it, copy, paste it, Control-R, or hit run up at the top. And this will tell me that, well, it's to my documents, C drive, blah, 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 my documents. I have saved my materials to this file path. So I would suggest to you to take a second here and put in the file path where you saved everything. I'll show you a quicker way to do that, but you can run this code and it will reset your working directory, this line. There's another way to do that, which is a little bit easier, and I'll show you this for one time. I believe it's under session, set working directory, choose directory. So if you don't want to have to type in all these // and C drive and everything, you can go up here and choose your directory. So you can see that I'm already at Dropbox USC Bootcamp 2022 and hit open, and it will actually paste it right here, right into the console. So you can do a quick copy and paste it here. I would recommend putting it in here in your script file. Keep in mind, if you're making changes to the script file, it's going to show up with red with an asterisk here. That means there are unsaved changes. So suggest hitting Control-S or file save or something like that. And I see a question: what's the difference between read_CSV and read.csv? I use .csv because I know that's a built-in command to R. Read_CSV, I believe, is part of a package or extension that has another family of tools. But I might be mistaken. But in any case, I tend to just stick with read.csv. So almost a half hour in, and we're almost to the point of reading data. If you're new or newish to this, as you know, it accelerates. So let's actually read in this data. I know I did it before, but once you've set a working directory, you can just read a file name by typing it in like this. And data equals read.csv. So once you've loaded in data, it becomes what's called a data frame. You can just type in data and it will show you the whole thing, but that's not really a good way to see it. You can see omitted rows, reached max, print, all this stuff does not really bode well. There are several ways that you can explore your data that are a little bit better. And starting on line 42 here are several that I like. Column names. And keep in mind too, data is just what I called it. Oftentimes I call my data D, D1, D2, something like that. I've just called it DATA for now. Column names gives me the column names of my data. You can see that there are 23 columns: regional ID, region, country, total population, CO2 per capita. These all correspond to the OECD data set that I've provided for you as a sample. N row, number of rows, is always useful. 453 rows, and these correspond to world regions. One that I like is head of data. That just gives you the first 5 lines of everything. You can use almost any name. There are some reserved words. If it's the name of a command, it can get confused, and it has to start with a letter. It cannot start with a number, to answer Paul's question in there. Head data just gives you the first 5 lines of everything. Great to tell you, is something pass the smell test? Is it a bunch of NAs or whatever? A little bit more sophisticated than that is summary of data. That will give you the minimum quartiles, mean, median, maximum of each data to kind of gut check. So now we know we're dealing with 453 world regions. I know from here that some of them are called, say, Ohio, Pennsylvania. Okay, there are US states. Tel Aviv district, that sounds like Israel. Calabria, Italy. And the last 2 I will ask my colleague John to perhaps pronounce, because I'm not as familiar with these 2 Korean regions, and I know he is. So we know we're dealing with 453 world regions here, ranging in population from about 30,000 to about 46 million. Interesting to see that world international data does have some vagaries, some NAs. You can see the COVID vaccination rate data. Actually, there are 237 missing observations out of 453. The last thing here on line 46 is just view data, view with a capital V. So if I type in view data, I'll get something handy and familiar. If you're like some of the students that John and I teach on this, they just breathe a big sigh of relief when they know that they can type in view data and actually see it in a fairly familiar way that resembles Excel. This isn't perfect. It doesn't always load it saves RAM, so you can't scroll all the way to the bottom without it refreshing like this, but it is sortable if you do want to quickly sort and see what the kind of lowest population world region is, or the highest. The highest is the Sao Paulo region of Brazil, it looks like. So with that out of the way, data, as you see, it kind of has opened up a new little pane up here, so I can X that out and get back to my script file. Let's go just a little bit further and then do a breakout room here. What we've done so far is to look at a data frame, which is kind of a matrix. You've got typically in data, you've got tons of rows and you've got tons of columns, but a lot of times you're just interested in one series. So you're just interested in the population series. So the $ is something that's used in R a lot to delineate between the name of the data frame or the matrix and to just grab one column or vector. So if I want to look at just the total population, I can type in data $tot_pop20. And you see, once I do a $, I get this handy little thing as I start typing that allows me to select. Tab can be used to complete it and enter to hit it. So now I have my 453 values for population in order. I can also rename if I want to. I have an object here called data, which is a matrix. If I want to just work on this vector of population, I can rename it pop. So pop equals data $tot_pop20. And now if I type in pop, I'll get the same population numbers. I can also do this set of descriptive statistics on a vector, like I did with the whole data frame or matrix before. Its length, it's 453 long. The mean population, about 3 million, median, a little lower than that, minimum, maximum, or the full summary here. In Grace, I'm generally what I'm doing here is I'm hovering with my cursor over a line and then hitting Control R, which I find to be the most convenient. But another way to do it is if your cursor is on a particular line of code, you can go up here and hit Run. Another thing that you can do, and I'll show right now, is you can highlight a whole bunch of code. And if I hit Run here, it's going to run all of those at once. So I'm sorry, you can't see me hitting Control R with my left hand here, but that's what I'm doing. Or you can mouse over to hit Run. All right, 2 more commands I'm going to teach you before we do a little bit of a breakout session here. What if we're interested in just looking at regions based on some characteristics? So we've got, I don't know, 20 or so variables across 400 world regions. What if I want to just look at a subset of the data that is with a condition? So this line here, 62, I'm going to do a subset of the data, and I'm going to give it a condition whereby unemployment in 2020 is greater than or equal to 0.1. So I'm going to isolate the world regions with high unemployment, and I'm going to save that selection of 453 observations. It's going to be fewer than that. And I'm going to save that in a new data frame called high unemp, high_unemp. So if I run line 62, again, I can copy it from the source code and paste it here if I'd like. I can type it in, but that's a pain in the butt usually. Or I can highlight it or just make sure my cursor is on that line and hit Run or Control R. And you see here it ran this. So if I take a look at high unemp, it's going to be a data frame. It's going to be a mess. So if I can do a summary of high_unemp, and I can see that it has all of these same categories here. If I run line 63, which is the number of rows, it's 80 rows, so it looks like 80 over 453. And if I want to see the percentage of world regions that have high unemployment, I can run line 64. It's gonna just do some simple math. You can always rely on math. The number of rows in the high unemployment divided by the number of rows total. You can see that 17.6% of world regions are high unemployment by this definition. Now, one of the things that's really helpful about R and why a lot of people use it is because you can do extremely customizable graphics. The example, probably one of the most frequently used commands is the histogram command, hist. So just put whatever you want in a histogram in these parentheses here. So if I'd like to make a histogram of unemployment across world regions, I can run line 67 here. So cursor over line 67, hit Control R, and then boom, I see a little histogram popping up here. This is the default histogram. It looks a little bit ugly usually. It uses, I don't know exactly, but there's something on the back end. This is part of the base R distribution, not any fancy package. There are many fancy packages that do better graphics, but this will give you at least a first cut without any labels or anything like that. So you can see that, certainly the majority of world regions are below 10% unemployment. The highest category is between 5 and 10%. Very few over 20%. Which seems to pass the smell test, always a good idea when you're working with social science or related data. I can make a much fancier histogram too, though. The way that, in a lot of programming languages, you've got something similar to this, but there's a histogram command, and the first argument that you pass to it is the data that you want to put in a histogram, but you can put a lot of other bells and whistles here. You can estimate how many breaks you want it to have, how many breakpoints. You can declare limits for the X range from something to something. You can give the X-axis a label here, XLAB is for X label, Y label. I can give it a color. There are tons of colors to choose from. I'm sure there's also a way to put in RGB codes, but if you want a color, you can probably just type in the name of that color and it'll work, and then a main title as well. So if I run line 68, you'll notice it also kind of wraps around. Because I didn't close the parenthesis on line 68, it actually bleeds over. So this is a single line of code. If I run that, I get a much fancier histogram of unemployment in world regions. You know, I encourage you to take this script file here and kind of as a basis as you're exploring, and if you want to extend this to your own work, and kind of go from there if you want to you know, change these things around or use it for different data, etc. Let's move onward to section 2, describing data in R. Are you ready? Thumbs up, thumbs down, sideways face. Okay. All right, let me just get configured here a little bit. And here we go. All right, so I've just opened up my console like I had it before, and now we're at about line 79, section 2, describing data in R. A couple of folks in the breakout asked me, well, how can you see all the things you've made, all the objects? Well, ls is the command for that. If you do ls and then an empty parentheses, you'll see all the things you've made. So I've got data, which if I recall is my whole data frame that I read in. I have a subset of data, which I named high unemployment, high unemp. And then I have a vector of just the population, which is another object I created. If you want to remove an object, if I wanted to remove high unemployment, I can hit remove unemployment and then hit ls again and see that that is gone. I can also remove everything by removing a list equal to all of my objects. I'm not going to do that just so that I don't have to read in data one more time. And a couple of things that I find helpful too. When you're coding, oftentimes you have something called a preamble. It's convenient to put a working directory up front. If you have any packages, we'll get to that shortly. It's nice to have that up front. And these two kind of, I guess you could call them global environment settings. I'm not sure what the official R term is, but if you run these things for your whole session in RStudio, they will be options. This SciPen kind of helps avoid some of the unsightly scientific notation. If you want to just use regular numbers. And then I've found a lot of the tabular data that I read in often has strings, so like a text stored as a number, or a number stored as a text. This doesn't help all instances, but this option, strings as factors equals false, helps some edge cases. So I recommend putting that in too. All right, with that, let us go to describing some more data in R. Jisoo, I think if in your environment, you may, I don't know, I don't have a good answer for that. Maybe John might, getting in some of the properties. I don't do a good job of tracking the data that I make sometimes. We've worked together. I think you probably know this. Any case, so let's go back to our OECD data. If you hit the remove command and removed everything, create it again as data here. I'm going to run line 91 by hitting Control R, let's make some other variables here. Take a look at your data. Head of data is always going to give me my really nice little summary of what I'm working with here. But what if I want to make a, I've got unemployment rates. I've got the number of senior population. But what if I want like the percentage seniors, a percentage variable? So I can just do simple math here and create a new column. I'm here on line 94. I'm going to create a new column called the percent seniors in 2020. And it's going to be equal to the population of seniors in 2020 divided by the total population in 2020. So if I run line 94 here, it's going to do this math. And then if I again do head data, just to kind of see what I'm working with here, I can see that I now have a new column at the end that I didn't have before called percent senior 20. You can see that in the region state, in this case of Ohio, 17% senior. What is this? Calabria, Italy, 22% senior, for example. Again, if I do view of data, It does sort temporarily. This will not get saved, but if I do view data, I can go all the way to the right to the new column that I made, and then sort by percent senior, and I can see the lowest percent senior is Mayotte, which I think is Overseas Department of France, if I'm not mistaken. Bonus points to whoever knows where Mayotte is. Okay, let me close out the data here and get back to the script. So if I'd like to, let's compare senior population share in 2005 versus 2020. I already made a column for percent senior in 2020. Why don't I make a new column for percent senior 2005? Easy enough. And why don't I do a little bit more math? How about percent senior increase? Data percent senior increase equals percent senior 20 minus percent senior 05. So kind of the hypothesis I'm working with here is that where are the regions where the senior citizen share has gone up? And really easy histogram in line 101 here. You can just run and hit R and take a look and get, oh, look at this. It's a pretty normal distribution, a pretty nice bell-shaped curve here. And even from this, I can tell that most world regions increased, almost all world regions increased in their percent senior citizen share between 2005 and 2020. Of course, I can always do a summary of just that variable, summary of data $, and oh, what did I call it? It's, well, oh, good, I can at least have it here. Percent senior increase. You can see a minimum of, you know, at least some regions went down, maybe just one or two. And then about 0.04 is the mean, and 10.7% is the max, with 85 NA values here. So easy little way to kind of manipulate some variables and get yourself a little bit better understanding of one of these phenomena that we're dealing with here. I'm going to go down to line 103 now, which is sorting. Now, I showed you how to sort in the view mode, which is nice because it's really quick to look at, but you can't manipulate that. That doesn't get saved in what you're working on. And what I recommend doing is actually to create a new data frame that is sorted by the desired column. So my data here is just sorted by however it's sorted from wherever it came from. The CSV that you read in was sorted this way, and Ohio happened to be first. I don't know exactly why, but that's the way it came from the data provider. If I want to sort by increase in senior share, I can run this command, and it's a little bit gnarly looking, to be honest. It's a nested command. I'm going to, what I'm going to do is kind of surgically operate on my data using these square brackets here, and then pass an order command with a comma after it. And then I'm going to do all this, and I'm going to make a new data frame called data2. Somebody in the breakout mentioned it gives them heart palpitations when they see something called a data2 because it's hard to track, but feel free to improve and do better as always. So I'll run line 104 and get data2. If I again do my favorite head command here, line 105, and run it, I'll see that the first one, the first region here actually has you know, the senior share decrease, which is kind of an oddity. It's the Brussels capital region in Belgium had a decrease in senior share. Perhaps they're seeing a lot of immigrants across, you know, from across Europe. That's kind of the capital of the EU in a sense. So I can imagine maybe a lot of young migration age folks moving there, and the senior share perhaps decreasing. You can repeat this in reverse order. What I've done here is just to put a negative sign in front of the vector that I want to sort by, and then again output to data2. So now my new data2 is different. And like I mentioned, you can use brackets to kind of slice and dice your data. It's a row column format. So what you see here, we do head of data a lot. That gives you the first 5. If you want to take rows 1 through 10, and then all of the columns, put 1 through 10 before the comma, and then leave after the comma blank. So this will give me, whoa, goodness, I'm going to redo that with a little bit more space here so that I can see. Convenient trick. If your cursor is down here at the chevron, you can just hit the up arrow to get to your last command that you ran. You can get to your last several commands that you have run if you'd like to. But let's just run this a little bit wider so that I can see it better. Now I have the top 10 regions by increase in senior share. So it looks like Hokkaido, Japan, I believe that's the most northerly island of Japan, if I'm not mistaken, had a 10.7% increase in its senior share of population. Went from 21% seniors to 32. So I hope they have a solvent pension system in Hokkaido. You can also kind of use the brackets to slice and dice just say the first 10 rows and also the first 5 columns using this kind of structure here. So I'll see this is not super useful because I have them sorted, but I don't have what it's sorted by, but just as a FYI for kind of some further slicing and dicing. Sometimes it's helpful to rank these things. You know, Hokkaido's number 1. Actually, the top 4 are all in Japan. Then we get some France, Canada, more Japan, more France. You can see who's aging the most here. But a rank field is nice. And this is a little bit gnarly, but again, it's pretty easy. It's a sequence. So I'm going to go a sequence. I'll just do it, you know, sequence 1 to 10 gives me 1 to 10. But if I do a sequence to, well, however long this vector is, I can make that a new object, and I'll call this SR rank. So SR rank is just a senior rank is just a sequence of numbers from 1 to 453. And then I can do this fun little function here called cbind. C stands for column bind. So basically I can take data 2, and then I'm going to add one more column here, which is my rank field. Run that, and I've got a new data 2. So head data 2. And I can see that now I've got a nice little rank field that identifies Hokkaido as the number 1 for senior increase and so forth and so forth. Lindsay, yeah, I believe you do need the comma. Let me check. Yeah, you need the comma. I don't know what this is. So yes. All right. Again, my goodness, I know like 7% of R. It's to find someone who knows 50%. That would be amazing. All right, so we've added a rank field. A little fun thing here. Let's do some comparative histograms. I find this useful from time to time. There are so many options and I guess a little bit more kind of global settings that you can pass in via a command. A lot of them are some variant of PAR or PAR. That'll give you some graphics parameters. And what this nicely does here is this stands for graphical parameters, and it specifies the number of rows and columns. So before, if I had done a histogram, and I'll just run line 117 for you, I get a single histogram like this. But if I want to compare senior shares in world regions in 2005, and then again in 2020, I can make 2 little plots here. So I'm going to run line 116, and then actually I'm going to run lines 117 and 118 all at the same time. So may as well highlight all 3 of these lines and hit run. And then I get this really nice convenient feature here of getting 2 side-by-side histograms, and it kind of indicates to me, you know, what's going on with the senior share. I can clear the plots by running line 119 again, and or I can clear them by sweeping them away using this little sweep icon here. I just clicked in the plot window. But why don't I make them a little bit nicer? Oh, I'm sorry. I'll just run 119 through 121 again, and get these with a little bit more bells and whistles, a little bit of color here. And consistent numbering, so they both go from 0 to 35%. And you know what else I can do here is I can add some guidelines. AB line or AB line is going to be able to give me a nice little guideline. And what I've done here is do a vertical AB line equal to the mean of the percent senior. So I can get the mean on here. I'm going to make that one black. I'm going to do line type 3, which I believe is dotted line. That's something you can easily Google or do a help. And LWD is line width of 2. So if I run all of these, lines 124 through 128, that's going to give me a side-by-side. That's going to produce my first histogram, give it a line, produce my second histogram, and give that one a line for its mean. So we're ready to go here. I can run all of these and get this really nice graphical output here of senior share in 2005 and 2020. Hit the export. I recommend honestly doing this. You can save it in text, but you've got a nice little thing here in our studio. And not sure why this is not coming up. Perhaps a copy to clipboard is a better way to do it. Yeah, and you can actually kind of modify it a little bit more here before you copy the plot. I'm not sure why the save didn't work this time, but it usually should. If anybody is a fan of a box plot, line 131 is a box plot. They're not quite as intuitive in my view, but they also kind of show that the senior share increased. And let's get into, now that we've got some histograms here, let's get into, once I, again, move a little bit my windows around, some more statistics here, some correlation analysis with this OECD data set. Again, a rich data set. Always like to go back to see what's in my data by just typing head of data and remember what I've got here. But let's take a look at the relationship between income and air pollution levels across world regions. So again, you can do a summary data or review data, but the command here is called core.test, correlation test. This is the output of a Pearson's correlation test. And it's pretty easy. You just pass in the X vector and the Y vector. Whoops, I don't know what I did there. And I'm going to run line 137 here so that you can see what the output looks like. And if you're into, I guess this is probably maybe intermediate statistics or something, you can see the degrees of freedom, the t-test scores, the confidence interval, the p-value. This must be some sort of an iterative method because it gives you 2.2 times 10 to the negative 16th as the p-value if it's converging to 0. And at the very bottom here, the correlation coefficient, it's a negative 0.48. So fairly strong negative relationship, inverse relationship, sorry, it looks like between income and air pollution. Higher income countries have lower air pollution and vice versa. Again, we're at the mercy of the OECD data and a limited sample of world regions. So if you're doing a research project or a hypothesis test, I would encourage you to look further on this question, but this works pretty well for an R intro. All right, so let's try to scatter plot of this because the scatter plot is really where you kind of see some of the correlation coefficients come to life here. I'm going to reset my graphical parameters to doing a single plot here in line 141, a 1-by-1 plot, because if I hit it, that kind of got saved in my global parameter. So I'm going to clear that out. And then I'm going to hit line 142, which is really easy command. It's a plot command. I'm going to plot income in 2019 against PM 2.5 in 2019, which is the air pollution levels. And I'll get a reasonable looking scatter plot here, plotting these two vectors against each other. And you can assume that you've got kind of a negative trend line here. Well, let's actually add that trend line, but it does take a few steps to get here. So bear with me, but feel free to just kind of run this whole thing if you're kind of falling behind or you just want to get it to work. What I'm going to do here is I'm going to simplify things a little bit, but then again, there's always a trade-off. I'm going to summarize. I'm going to call data income 19. I'm going to call that X, and then my vector for PM 2.5 air pollution, I'm going to call that Y. Now I have an X and Y that I have to remember what the heck is X and what the heck is Y. And then I'm going to do a really simple, it's actually a 2-variable regression, and I'm going to save the output to an object I call model. So if I model X and Y, I get a summary of a model. This can be a multivariate regression too, if you want. I'll get to that. But if you want to plot the scatter plot, you want to use the model output for it, and it'll give you a really nice little legend as well. So what I'm going to do here is actually I'm going to also do a correlation test, assign that to an object. That's something you can do a lot in R, is assign commands to an object so that you can use pieces of them later as you please. So something within the object, which I've now called outcore, is the estimate, which is actually this correlation coefficient of negative 0.8. And I can do, as you can see here in line 153, I've added a lot of bells and whistles, made the labels nice. Let me run that. Slightly nicer. if I run line 155, this AB line, I don't know how to pronounce it. I don't know if it's intended to be pronounced. But if I take my model output and do that in the line, that'll give me the trend line here, this negative trend line, and a nice little legend here on the top right of the correlation coefficient. So this is a reasonable plot that might pass muster in a publication or something like that. But you can really clean it up. And in the interest of time, I'm just going to run lines 160 through 168 here. I'm going to plot. I am going to add a trend line, and then I'm going to add a few convenient pieces. Took me a while to figure out this chunk of code here, but I do find it useful. Feel free to use it yourself. That's the beauty of open source. And get a nicer looking scatter plot here, comparing income of world regions and particulate emissions. So you can see on the top right, you've got your correlation coefficient. That's actually a small mistake. That's the absolute value of R, not R. It should be negative. Maybe you can make it squared. Your beta value for the intercept, and then a p-value for the statistical test. If you really want as well to label some of these things, this is kind of a lot of observations, but sometimes if you only have a handful, you do actually want to see the label next to them. You can add something to the existing plot by running another line of code. And this command is called text, and it's really just going to add whatever this label is that you declare. And I'm going to actually take, I want to kind of get a flavor for which countries are where. I don't know all the world regions, but I do know that I have a convenient 2-letter country code that's fairly intuitive. If I see US, I know it's US. If I see CA, it's probably Canada, et cetera, et cetera. But so I'm going to run line 169 here, and it's going to put a really small, because I've told it to be small, the CEX means scale this to 0.5 of what it actually is, a really small label here for what the country is associated with each of these. And as I put this together the other day, I got a little bit of pause because, well, is it all the U.S. regions or U.S. states up here with higher income? I do wonder if there's something with the currency conversions or whatever. But then again, you do see some regions here. I know, Poland, for example, has some particularly high emissions because they're very coal dependent for their energy sector. Australia kind of here. So this gives you a little bit better of a feel for which parts of the world, what's actually underlying your data. So let me hide this plot away, and we've got one other little tips and tricks section here before doing another breakout, and actually we'll take a full break so that we can get a breath of fresh air here. But just a little bit of dealing with missing values. I know somebody in the breakout asked me about some data cleaning, but I'm going to use the example here of the broadband data. So again, if I do a summary of my data, I can see that I have somewhere here, whether or not there is broadband access in this world region. And it looks like in most cases there is, but I've got a lot of NAs, 198 NAs here. So if I want to, this might be percentage of the population with broadband access. We probably want to check the metadata before going too much too further into this. But if I want to calculate the mean of broadband access, it's going to give me an NA in this instance. So you can always add the arguments to the some commands that you need them to be all values. You can get rid of the NAs by saying NA remove equals true, NA.rm equals T, and then it will give you the mean of all the non-NA values. So one way to get rid of all the NAs, if you'd like to, is again, like we've been doing, make a new data frame. Make a new data frame that gets rid of all of the observations that have an NA in broadband. So if I'm doing a more extensive analysis on just world regions that have broadband and I want to jettison all the ones that I don't have data for, I can make a new data frame called data 3. Again, the gentleman in the earlier breakout session said, oh, please, for the love of God, pick a more intuitive name for it instead of data 3. That being said, I'm going to just move forward so that we can get to the more interesting parts here. So I have done data 3. I can look at how many rows it has. And I must have made a mistake here because this should be fewer than 453. Oh, I'm sorry, that's data. Data 3 is 255. My apologies. So I have 255 good observations for broadband. I can remove a column by setting it to null this way. So previously we made this percent senior increase column. If I want to get rid of it, I can remove it and then see if I check the column names of my data, it will not appear at the end. I can also extract just the first 4 columns or however many columns of data using this. So, all right, let's get back into it because we're going to get into section 3 now, and we're going to blast through a handful and then do one more breakout at the end, where hopefully we have some time to kind of chat about potential use cases or other things we may have seen, or just what you think about Census API or the tutorial overall, because again, that's the objective. We'll get there, don't worry. So let me share my screen and dive right in. I'll leave it right where we had it before. So we already went through basic data skills. We went through some good ways to describe data. Now we're going to get into some tips and tricks that I've just found really helpful when working with data and spatial data in particular. And one of the things that I absolutely love R for is merging multiple data sources together. We've got to do this a heck of a lot in any type of social science analysis or hard science analysis too. So the example that I have has 3 data sets that are all in that folder that I gave to you. One is from the State Department of Finance, one's from the Bureau of Labor Statistics, and then the third one is going to be from the American Community Survey or Census Bureau. And we're going to play around with getting them together. So the research question here is what predicts domestic migration across California counties? Is migration a little bit more driven by housing cost or is it driven by job growth? You think that high housing costs maybe pushes people away and job growth pulls people in. So let's take a look at this with the data that we have. Not a perfect answer, but good enough for an R tutorial. So again, remember you have this nice folder here with all of the kind of sample data for this exercise. We'll be reading in a few of these CSV files here. And there's a little bit of metadata kind of linked into the notes here. One thing I didn't mention, you've probably noticed already, if you start with a pound sign or hashtag, that comments out the line of code. So, so that will not run that line of code. It's just a note. So let's start here with line 197 and read in our DOF data from the State Department of Finance's Demographic Research Unit. I'm going to read it in and I'm just going to call it DOF so that I can keep it straight. I hope somebody has figured out a better way to keep track of data than I have. So always, you can just take the head of your DOF data and see that, all right, it looks like I've got counties in California. These look familiar, Alameda, Alpine, etc. They've got a couple of different ID fields. They've got a field for the MPO or Metropolitan Planning Organization that they belong to. These regional agencies like SCAG is one of them. And then you'll see they have population, births, deaths, natural increase, which is births minus deaths, immigration, and domestic migration. So immigration is the net number of people from other countries, and domestic migration is the net number of people from other counties in the country moving to or from. And I've got these data for 2010, this whole set for 2017, and then again for 2021, the most recently available. In terms of the number of rows, I've got 58 rows corresponding with 58 counties in California. So we're probably about 5 minutes over on time. So I'm going to skip the step where we download census data the old-fashioned way from data.census.gov. I'll just direct you to the website itself if you're not already familiar. This replaced the old American Fact Finder, which was not terribly intuitive, but it was at least familiar. There's probably mixed reviews out here. This has some advantages and some disadvantages, I think. But you can do advanced searches, filtering by geography, by codes, topics, years, etc. I don't find this terribly intuitive for my work when I'm usually interested in getting county level data or tract level data on a very specific program. That's one of the reasons I prefer to use the API, which we'll get to today, a little bit better kind of auditability, you might say, for the data. In any case, what I've done here is to give you instructions on how to grab the, what is this? Sorry, median value of owner-occupied housing across the 58 counties of California. But I've also included this in your data folder of sample data. So if you want to grab it yourself, you can follow these instructions on how to get it, or because we're running a little bit over on time, I would just encourage you to run line 209, which will read this data in. It's got a junky looking line of code, and I put this in here to give you an example of how to deal with a situation where you have multiple headers. The census data comes with two headers, the name and then a code. So this will kind of read it in as though it's just regular data. So I can run line 209 and get my ACS, and then I can run line 210 and see what it is. You know, when you get this from the Census Bureau, you'll get a nasty looking code here. Usually ones ending in E are an estimate, which is the actual data you're interested in. And it's the median home price. You can see in Alameda County, which is Oakland, a median owner occupied housing price is $825,000, which is insane, but that actually kind of checks out for Alameda County, I would say. Alpine County, a small Sierra area county, 372,000. So these look like home values. So let's move forward here. M is the margin of error too, if you're interested in that. I've also processed some job data for you from the Bureau of Labor Statistics. You can see a little bit more info in the link there. But on line 213 here, I'm going to read this in, and I'm going to call it BLS. And again, I'm going to take a look at BLS and see what I've got here. Again, a GeoID, some IDs for the county, and you'll notice that these can be all over the place. It can be tricky to match. You do have to make sure that you have a common identifier if you're trying to match, in this case, county data from a few different sources. But what I've got here is just total employment in a bunch of different years, the June 2015 numbers, 2016, all the way through June 2021 for each county in California. So here's the real meat of the operation. And this is a little bit tricky and wonky, but I promise it's worth your while. Give me a little thumbs up or something, a reaction if you are familiar with and have used VLOOKUP in Microsoft Excel. Is anyone familiar with or has used VLOOKUP? Not sure I can see. Oh, 21. Okay, I can see the number of reactions. That's cool. Great, thanks. I love using VLOOKUP. All right, some love for VLOOKUP. This is excellent. Sorry, I just opened the chat. I see another question. Tom, if you wouldn't mind hitting the giving the link to the code for someone who joined in, and Dr. Radyansky, the -2 gets rid of the second line in that when you're reading it in, and that's just because the Census Bureau data happens. If you get it from data.census.gov, it has a double header line, so that will nix that if you just want to do it, not have to scrubbily get rid of something in Excel as a manual step first. All right, so let's dive into this command, and this is called the match command, and it's basically a VLOOKUP. If you're familiar with that, it's going to be, we're going to start with, I'll scroll up here so that we can see DOF. We're basically going to be adding columns to this data frame called DOF. We're going to add the jobs data to the Department of Finance, births, deaths, demographic info, and then I'm going to add the housing data to the same thing. And the objective is to have all these pieces of data in a single matrix, in a single data frame. Then I can do correlations, I can do maybe some mapping, et cetera, et cetera. So let's take a look at the syntax here of line 219. Basically what I want to do is I want to make a new column in the DOF data frame called HOVAL20. So I'm going to grab the this column from the ACS data, the home value column, and then I'm going to use brackets to invoke this match command here. And what's inside of this match command is where I can declare the common identifiers, or the key value, sometimes it's called. So in the DOF data, I have a field called ID, which is this nasty looking string here that has some codes, US, I guess for US, and then something that I recognize here as a county code from the Census Bureau. But it's this long thing here. And in the ACS data, I have, looks like I've got a field called GeoID, which is the same thing. And these both happen to be sorted alphabetically, but you never know. I'm very I'm not very trusting of some of the data sources, and if you want to reduce the share of time you spend on data cleaning, my recommendation is to do it right the first time and join by a code or an ID value instead of a name. For example, if I were to use the field name in the ACS, it says Alameda County, California. Well, that's not going to join to the field in DOF, which just says Alameda. So best to find a GeoID or something like that. And I have prepped these data for you. Everything's going to come to you a little bit differently. So keep an eye on that, because that's a lot of the data cleaning effort. So what I'll do here is I'm going to use this matching feature here to add a column to the DOF data that matches the home value data. And if I take a look at DOF after I've run that by doing head DOF, I'm going to see that now I have a new column here with the home values by county. I can also add some of the employment fields. What I can do here is I can make a new column called DOF EMP21, and I can grab the 2021 employment from that BLS data frame, and again use this structure of brackets and then a match command to invoke the key in my DOF and the key geo-identifier in the BLS data. And in the BLS data, that one is called a GeoID. So just make sure that you've got the column name right. Again, the syntax in R can be pretty finicky. So I'll run lines 220 and line 221 here and do a head of DOF and see that, oh, look at this. This is convenient. I've got the home value employment here and employment here alongside all of my other demographic information. So now I can do that. I can do that matching here. And like I mentioned before, you can always do math. So you can make a new field called population growth from 2017 to 2021. And just do some math here. 21 minus 17 divided by 17. I can do employment growth from 2015 to 2021. I can run these here. And why don't I just to mix things up, I'll do a summary of DOF and take a look at the mean employment growth, 4.7% over this time period. Home value is still here. Population growth about 0.08%. So employment growth on average really outpacing population growth in California counties. To some of your questions, does it leave blank if county is missing from one file? The data that I've given you here, it's 58 observations in each of these. We have all the counties. It will show up as an NA if it's unmatched. So if you remember in the OECD data we were working with before, and I did a summary, some of the values were NA. It'll show that here nicely in the summary if you've got unmatched values. So that's one way to check and go about it. And Caitlin from Culver City, hello. Can we just combine two data sets into one? You can. There is a command called cbind, column bind, which I think I have a little bit earlier in the script. And that would actually, in this select instance, it would work because we have counties and they're alphabetized. But say, for example, you have Bureau of Labor Statistics data that has all 3,000 counties in the country, and you want to get employment data from the whole country into your other data set of just California counties. Or you have another one that has some missing values, or you have another one where they're not alphabetized. Maybe it's sorted by some other feature. There's certainly a risk to doing this combine command. And I think one of the strengths of the approach here or the VLOOKUP command in Excel is that it's going to work regardless of the order of your data. It's going to use this identifier. It's going to use an ID field to match it no matter what order it's in.
Oh, thank you, Sarah. A quick question then. So the match actually just you have to add column one by one. So what if you want to combine multiple columns into another spreadsheet and you still want to match with the same identifier? So is there,
you can write a loop. That's the way to do it. If you're I can send me the email, Kane, K-A-N-E at scag.ca.gov. I've got a little snippet of code that can do that. I do not have it here because this is a little bit of the intro course, but that's a way to basically match everything from one data frame to another.
Got it. Thank you.
Yeah, you can write a loop. All right, so this is, again, highly recommended to just make sure that you get the data right the first time when you're matching. So lines 224, 225, what I've done here is I've gotten some population growth, some employment growth as fields here across the 58 California counties. Now let's analyze it a little bit. Let's analyze this using a plot. So histograms are really great for just kind of exploring your data, seeing how it's distributed. Here in line 231, if I highlight it and click run, or if I highlight it and do Control R, I'll get it and I'll see population across California counties. And my goodness, LA County, where I sit and where I imagine a number of folks sit here, is a really far outlier. If you're looking at counties across the state or the nation, the vast majority have, well below, let's say, 500,000 population. If you remember math class from back in the day, logarithms are a good way to kind of smooth out a lot of the distributions of socioeconomic data. So I can take a log of population and do a histogram of that. It's going to give me a lot more nice of a normal distribution here. If you're doing correlations, logs do really help in a lot of instances, but that's a more advanced statistics topic than we've got here. Remember, we've done some box plots too. We can do a nice little side-by-side box plot of employment growth and population growth. I'm going to hit line 235 right now. Again, this doesn't have many bells and whistles, but this kind of is generally showing that the rate of population growth, granted it's over 4 years instead of 6, is way below the rate of employment growth in most California counties. So that generally tends to be telling us that folks are working longer, they're working harder, they have more two-income households. Man, it's an expensive place to live here. All right, let me close out of these little box plots here. And then give you a scatter plot just to kind of understand, one variable and another. Certainly one of the reasons that we're trying to combine multiple variables is to understand how they relate to each other. Again, like I did before, I can kind of do some shorthand here. I'm going to say X is home values, and then Y is let's do the log of population. Let's do the logarithm, because that's going to give me a better, more intuitive correlation, because you've got tons of small counties and a few really big outliers. So that'll smooth this out really nicely. And if I do a plot, I can get this convenient little scatter plot here, which is just showing me this really basic relationship between population and home values. If I do a correlation test, I can see here that I've got obviously a positive correlation, and a pretty strong one too, you'd have to say, between county size and home values. Again, not the most interesting hypothesis, but it works here. And like I did before, you can do a much fancier scatter plot with a few things here. You actually end up modeling it with a linear model. You do a plot. You can put a best fit line and a handful of other things in the legend here. So again, I can just highlight all of these lines and run them at once, hitting Control R or the run button at the top right. And I get this pretty nice looking scatter plot with a best fit line relating home values with the log of population size. So the highest population county is probably here, LA County, at the top. And you know what? I'm going to actually add one more piece to this, and I'm going to steal from my previous code. Bear with me here for a second. It's this text line. This is an example of kind of adapting something. So if you recall, in the previous scatter plot, I had actually labeled, and I really kind of feel that labeling could be helpful here. So let's see if I'm able to do this on the fly here. I may or may not be able to do this. So bear with me here. Now, let me try it again with a little bit bigger text, rerun the entire plot, and see what we've got. Okay, well, this, you know what, this isn't perfect, but this kind of tells me where some of these are. San Francisco, a really high outlier here. In the relationship between county size and home values. LA, an outlier kind of in this direction. and a big cluster of counties kind of in this middle section here. So, all right. So that is lesson number 3, working with multiple data sources. I see some activity in the chat. John, Tom, anything that's kind of for the benefit of the whole group, or you're able to get most of these little issues?
Yeah, Kevin, one question I think worth mentioning maybe about some errors. If anyone has an error by running like line 225, it means line 220 and 221 did not run correctly, or maybe someone skipped that line and went over to straight to 225. So if there's no variable or column created, then line 224 or 225 would not work.
So I'll demonstrate this, and thanks, John. I'm gonna rerun from the start here. I'm gonna skip lines 220 and 221. See what I've got in my DOF data frame, and you're doing. I'll always take a look at your data. See where it is, and then if I try to do 224 and 225. I'm going to get an error message because I have not yet created one of these variables yet. I cannot do DOF employment growth in this instance because I have not yet added employment to the DOF data frame. So red text is not good. Thanks, Tom, for answering that, the code resource. All right, any other questions or things to bring up, John or Tom or anyone? On section 3, multiple data sources. All right, super cool. Let's move on to number 4. Again, if you kind of get behind a little bit, I recommend just running a whole chunk of code at once to kind of get where we're at and going back. I want to talk a little bit at the start of this section about packages. I mentioned this before. There's a lot of additional functionality. You can see a gigantic list of packages. I can't remember exactly where it is. Let's see. If you were to install packages in RStudio, oh my gosh, they don't even list them anymore. You just have to type it in, but it's thousands. Or here's a list just to give you a sense of it. Never mind. All right, it's a long list. So you need to. The thing with additional functions and additional packages is that if they put all of them into the base distribution of R that you get to begin with, it would just be way too big, and 99.9% of the people wouldn't use them. So you do have to install individual packages if you want to use them. Here are 3 that I would recommend going with. SF, which does mapping, do by, which summarizes data really nicely, and then foreign. This kind of helps you work with the DBF file format, which gets you ability to do some nice manipulation of shape files if you're into GIS work. So I have already installed these, but if you run lines 263, 264, and 265, it will install packages. You can also install them by going up here, I believe, to there is a install packages here in tools, but you can also, like, RStudio is a GUI. It wraps a lot of the commands in kind of the more intuitive ways. But if you run these 3, you'll install 3 packages: SF, do by, and foreign. So go ahead and do that right now. I'm not going to do it because I already have them. Then once you've installed something, you have to invoke it. You have to start it for this session of R, for this working session of RStudio. So you have that command is called library. So I've already installed, and if I run library SF, library foreign, and library do by, it looks like I need to do. I'm going to do a quick reinstall here. Or sorry. Because it's asking me to do a reinstall. So it looks like, all right. So if I'm able to successfully run all these libraries, I'm getting a message just saying that it's built under an old version. That's not a problem usually. give Tom or John a quick message if you try this a couple of times and it's not working through. But this is these are the 3 packages that the subsequent commands are going to use here. So a handy trick is to be able to summarize data at different spatial scales. So I'm going to stick with this DOF data for a little while. And I stuck a field in here called MPO for the Metropolitan Planning Organization. We've got 58 counties in California, and most of them are in various regions. I think there's a comment. I think you could just go ahead. Sometimes just give a shot at the next steps. Occasionally packages will ask you to do a reinstaller in our tools, but it's not. I would just move forward. It'll probably work. 75% chance. So sorry to distract, but back here, I've put the Metropolitan Planning Organization, if there is one, if there is a major one, by the counties. So let's look at how many different ones there are. And here's a little handy way to see how many different types of there are 5 unique entrances here: ABAG, Association of Bay Area Governments; Sacramento, Council of Governments; SCAG, ourselves; and then SANDAG, San Diego, and then a category for ones that are smaller regions that don't have a full-fledged MPO here. I can also do a table of DOF MPO, and that's going to give me how many counties are in each of these categories here. I can also see how many unique ones here. I can do another nested command and see, oh, there are 5 categories here. So this is kind of what I want to be able to do here. What I want to get to is kind of flipping between spatial scales. So I apologize for jumping around, but I've got a nice little example with that OECD data that we worked with before. Hopefully you can just in line 281 read that in again if you need to redo it. Take a look at line 284, do a table by country. You can see countries all over. US has 51 regions. This correspond to states plus DC. And you can kind of get a feel for what some of these other countries are. If I nest a sort and a table command, I'll get a nice list here that's sorted in decreasing order in this instance by countries with the most regions to countries with the fewest regions, several with only 1. I think, Shannon, you were asking me about this earlier. This is the bar plot command. So a bar plot is just kind of a really nice, not quite a histogram, but it's going to give you by category. So it will tell you how many observations there are in each category. And if you see what I just did here, because of the size of the label, I had to make my plot window a little bit bigger, but I can see how many regions are in each country this way. So again, the bar plot command, but you do have to do a bar plot of a table, or in this case, even better, a sorted table. Sorted with a T, apologies, and you're able to add the various graphical parameters, colors, what have you, as arguments in that command too. So those are bar plots. Thank you, everyone in the chat for kind of helping to troubleshoot the various package issues. So let's go back to the DOF data set here for a moment, and I'll plop it up again in terms of a head of DOF so we can kind of look at it. But I want to kind of collapse some of these by the region, and the command to do that, it's part of the do by package. It's called summary by. Unfortunately, it's not part of the base R distribution. You have to add a package. And what you do is you pick which values you want to summarize, and then you pick the scale you want to summarize them at. So in this case, the field indicating the scale is MPO. So I'm going to collapse these into the Bay Area, Southern California, etc. I'm going to tell it which data frame to start with. I'm going to use the DOF data for this, and I'm going to give it a function. I'm going to tell it to sum. I can also do means, medians, whatever, but sum is, let's start with sum. So I'm going to run this summary by command, and I'm going to put the output into something I'll call DOF sum. Whoops, I have to rebuild my DOF data because I did that example previously where I messed it up on purpose. That's the nice thing about some of this is you can just rerun a bunch of the things that you had done previously. So apologies for that little intrusion here. But I'm going to get back to line 291 where I was here before with DOF sum. So you run line 291, and you can just type DOF sum, see what it is, and you get this really nice little table of the population and the jobs in each of the regions in California. So the Southern California region, 18 million people. I love this example because it just shows how much smaller the whole Bay Area is, even though it's 9 counties, and how the north-south dividing line for population in California is approximately Wilshire Boulevard. Be a little bit careful when you get to line 293. And I would advise this when using the mean function or anything else to summarize from one spatial scale to another. You know, there's only one county in San Diego. So if I'm going to try to do the home value, you really have to be cognizant of what your observations are and then what the other scale you're summarizing by. So if I want to summarize you know, what the mean home value is across counties in California, the mean number of immigrants to that county, it's not going to be really well divided. So San Diego, this is the same as the San Diego value. Jisoo, thanks for that question. The tilde is here to separate the variables that you would like to summarize, which in this example here are home value and immigration, and the variable that you wish to summarize them by, which in this case is MPO. So we're working with county level data, but summarizing it at the MPO level. So this would be, in this case, what is the mean across the however many counties in each MPO region of home value and immigration. Really convenient if you're going from city to county to state, et cetera, et cetera. I wanted to sneak in how to write data here. So the summary by gives you this nice output command where you get this nice little table here. And as you remember at the very start, we were working in a working directory. So if I use this write.csv command, I can take my object to DOF sum, which is this little table here, and I'll give it a name and a .csv file extension. If I run line 297, nothing seems to happen in R. But if I open up my file directory, I see that I have a new file here called DOF sum table. I can open it up here in Excel and see the beauty of the write.csv command because I now have a little table that I've outputted here. So that's how you output things overall. And Hike, I could not find the function summary by. That function is a part of the do by package. So make sure you install the package and then invoke it using the library command at the start of section 4. All right, I'll just give you a few other tips and tricks here. You can make a bar plot of this summarized MPO data. You know, the number of population by each of the 5 parts of the state of California here. That's just a bar plot command, and that's actually a bar plot of this tiny little table you did here. But you can make it look a heck of a lot better. And here's a chunk of code to do that, lines 303 through line 306. A lot of bells and whistles. The axis kind of will give you the scale. This ab line here will give you these little lines here, and you can make them dotted. You can make them dark gray. You know, you can make them red if you want to. You can make them cyan number 3 if you want to, for example. You can also do some summarizing of the OECD data. And I'm going to go fairly quickly through that. I apologize just because I want to make sure that we get to the census data. But if we're here at line 309, I'm going to basically summarize the OECD data by country. So if you look at the head of data, which is our what we call our OECD data, you'll remember that I've got 453 regions and they're split by various countries, and you have this field called country. So if I want to summarize some of the variables by country, I can summarize the area, the sum of the area, the sum of population, the sum of CO2 per capita, or something like that. Across areas. And in this instance, I've done summary by, and I've created an object called out. And look at that, I've got a list of countries by area, by total population, and by the sum of per capita carbon emissions, which again is not a great measure. You probably need to do a total rather than a per capita. But in any case, we're splitting hairs here. You can do some sorting here. And, this is a great new opportunity to see, is there a kind of a relationship? Again, there are some issues with the data here, the way I've summed it, but is there a correlation or is there a relationship between, say, the size of a country and the carbon emissions of that country? And we're able to get that even though we don't have country data, we have region level data. So it looks like in this sense, 0.73, that's a positive correlation, pretty strong. And that's pretty solid there. So I'll leave with this section 4 on summarizing data with this one last command here, which is again LM, which is a linear model, which is how you do a regression model. And the syntax for that, and apologize for speeding through this, is you want your Y variable first, your dependent variable, and then a tilde. And then all of the independent variables or X variables you want separated by plus signs, and then a comma, and then declare which data set you're using. So let's go to the DOF, the data set called DOF. And my hypothesis here is going to be that, well, I think that domestic migration is a function of population size. Obviously, I want to control for population size. It's a function of home values. And I'll just use 2020 just out of convenience because I have it. It's not perfect, and employment growth in the last 5-year period. So I'm going to move to a place if it presumably has lower home values, and presumably if it has recently experienced employment growth. And let's run this model, save it as M, and then do a summary of M. And then if you are, of the analytical ilk, and remember, applied regression and analysis class in college or grad school or whatever, you'll recognize some of the relationships here and this pretty standardized output table. You can see that domestic migration is negatively or inversely related to population size. That certainly makes sense. This is more of a control variable. You'll see that it's negatively related to home values, actually. So people actually tend to be moving more toward places with high home values, and positively related to employment, which is kind of the expected sign. You're moving toward areas with employment growth. So just a little bit of code there for you on migration. So we've got a few more sections left in about 35 minutes. I do see a lot of kind of questions here. John, Tom, how are folks doing with packages?
I think we kind of got some issue resolved with Carla from UCI, but there seems to be more error there with installing the packages. So I don't know if it's on the server side or their machine.
A couple workarounds again. Just try again to install, close, and go back into R. Sometimes that will do it. Occasionally, generally, you don't need admin privileges to do packages because it installs it as though it's a file. It's not a separate executable. Oh, Grace, I see. That might be. I'm not sure if there are other Mac users who may be able to chime in if they've had an issue as well. I don't know all of the details of that, but again, remember it's 2 steps: an installation and then invoking the library here. I would generally recommend the usual cadre of troubleshooting things from make sure you save, of course, but then restart your RStudio, check if that works, restart your computer if that works, although that's a bit of a big thing to do right now in a Zoom. All right, so we've learned how to kind of go through data at different spatial scales. This is going to be a fun one, and I am going to open up my GIS right here for just a second so that I can have that ready. And actually, this is a bit problematic here. So yeah, sorry, I'm seeing some various folks with versioning issues. and John, Tom, maybe you can help with Shannon or Grace or whomever there. Let's get to, give me a quick reaction, folks. Who is a GIS user or does spatial data in any sense? Hit a hands up or a thumbs up or something like that. All right, we've got a fair bit. That's great. So one of my frustrations when trying to work analytically with GIS data, if I want to bring in something else, like for example, we were looking at counties in California, and the data set that you have is about demographics, but I want to bring in jobs and I want to bring in home values and other things from different sources. There are ways to do that. You can join tables in GIS, but I find it a lot easier to do it in R using that match command, and it's just much more reliable. And then you know where it's saved to. Typically for this, I work with the shapefile format, which has 6 or 7 or 8 or 3 different components, all with the same name. 8 in this case, which I've given you in the sample data. These are just counties in California. And what I'm going to do here is I'm going to read in a blank data set, and this is using the SF package. I'm going to read in a blank data set of counties in California, and I can do head, and just see that it's the same thing. I can do the number of rows in shape and see that it's 58. But what I've done in here is I've read in the DBF component of the shapefile, which is the tabular data part. Be very careful with these key variables. Like I mentioned, the ID number, the GeoID, whatever, can be quite finicky. A lot of times with census data, you have a leading 0 here, which is a little bit annoying. So what I recommend doing is kind of my little fix-all trick, is to create a new variable in the shapefile, and I usually call it GeoID2. And I basically take a character version of a GeoID and then a numeric version. And then I'll do this, and this will solve, I don't know, 60% of my issues usually. So a little bit of a data cleaning trick in R. Then I have a nice GeoID that's just a numeric value. In this case, it's 4 digits, which is the county code. So previously, we worked with the DOF data and had population, home value, and employment in it. So what started out as a regular shapefile, now if I execute a match command, I can add 3 more variables to this. And I can see now if I do a summary of the shape file that I now have population, home value, and employment. Now you can very carefully rewrite this to the original DBF. So remember the write CSV command. Now there's a write DBF command. And what I can do here is I can write to the shapefile. I'm going to copy this over somewhere where I remember it and just show it to you in GIS here, because I can. In my catalog, and I'm old school with ArcMap. Apologies, never got to ArcPro in my professional career here, but I believe I've got this here. Oh, apologies. Here, my 58 counties in California. Open the attribute table, and then boom, here's what I added. So I can really quickly and easily kind of go back and forth between R and ArcGIS, and for example, make a map of employment in 2021 by California counties. Just be very careful when you hit that write DBF command. All right, now back to R. That was 5, manipulating shapefiles. Hopefully a helpful tip and trick. Number 6, I'm just going to really quickly do this mapping made simple. This is the one that requires the SF package, and I'm going to work with that same shapefile that we got here. I'm going to read it in, and I'm going to call it counties. And recall that I just manipulated this shapefile already to add in some info. I can do head of counties. It's reading this in as a different object. SF is a package that does a few different things. I'm not reading in just a DBF file or just tabular data. I'm reading in something with a lot of objects here. If I want to just extract the data itself, I can use this command to just extract a data frame. But the fun thing here is that SF has a plot feature. And the command plot, when you have an SF object, a spatial object here, you can take a column of your shapefile here and just make a choropleth map of it. And if you're familiar with Census Bureau polygon files, they often have land area as a land. So if I just run this line 364 here, I'm going to get this really nice, well, not really nice, but look, a map of land area. And it's even got a scale on the right here that'll show that San Bernardino County is far and away the largest county in land area in California. Now, I've already added the population field to this, so I can plot using these brackets and quotes too. I can plot the population, and oh, look at this. Los Angeles County is far and away the largest here. So a little bit more of an advanced version, I've put a link here if you're interested in mapping with SF. I'm not a big fan usually of doing mapping in R, but it is kind of fun. A lot of the options and things you have, there's a link here. So I've added some bells and whistles to this command in line 371, and I can run it and I can get a reasonably nice little map here of population in California counties by using Jenks optimization with a title, using a palette of 10 colors here that works pretty nicely as well. All right, let's get to the meat of this, because I think right now we finally have enough skills to get into using the Census API. And this is going to require one package. So hopefully that works. Again, trying a different CRN repository might be one way to troubleshoot. But we're going to do two other packages here in order to get to section 7, the Census API. Install Tidy Census and then this other one called Tigris. And then if you've so hit install, I'll reinstall. You can always reinstall. I'll handle the pain with everybody here, but I'll run these 6 lines here. Reinstall, and then invoke these 4 libraries. Give you a second here as well. While this is going on, Paul, I see your question about can R choose patterns in maps and in bar graphs? Again, I'll answer yes, but I don't know exactly how. And Mike, I think you can you can kind of collapse chunks of code if you're going to use them frequently. So has anyone used the Census API by any chance? While this is loading up here, just try to gauge from folks. So a few folks have used the Census API. All right. I think it's great because again, like I mentioned, this data.census.gov sometimes doesn't have the greatest audit trail for all of your data from source to output. And with this now, you've seen kind of the mapping capabilities, but the data that I've given you is already kind of prepackaged. In this workflow, you'll be able to actually get your own raw data. Now, line 391 has a URL. Copy it and open it up in a browser. This is the sign up for getting into the Census API. It takes like 30 seconds. They just kind of want to track generally who's using it and your email address. And it should email you a key in like 30 seconds. So go ahead and do that. Again, it's the link on line 391. I'll put it also in the chat here. And they should send you a key. I have mine here on line 392. And it's this junky alphanumeric thing. So mostly what we'll be using here is this package called Tidy Census. And Tidy Census is kind of a wrapper. They have built a lot of convenient commands for extracting things from the Census Bureau's API to make it a lot more usable. You can access APIs through tons of different coding languages. I heard some folks talking about pandas within Python. I think this is what they've done with Tidy Census is a really convenient way to get census data through the API. So hopefully you've checked your email and have a code here, an API key. I'm going to run line 392 and invoke my census API key. It's going to say I need to restart. I don't think you actually need to restart. That's never happened to me, but poke around. You might take a couple of tries here. Now there are, if you're familiar with the Census Bureau data, you've got your decennial census, which comes out every 10 years and has a very limited selection of variables. Basically just people, race, ethnicity, number of households, number of housing units, the real basics of demographics. But then the American Community Survey, or ACS, gives you this really big wealth of information, which is not 100% certain. It's a sample, but that's what you're going to actually get: income data, detailed housing information, et cetera, et cetera. I shared my handful of favorite census variables at the very beginning of this. So I'm going to run line 395 here, and this is going to be this is the command called get decennial. I have told it all of the parameters that I want. I want the geography to be at the state level. I want this variable code. This is median rent. I'm going to tell it the summary file, and I'm going to tell it the year. So it's going to actually grab median rent from the internet, and it's going to give me this this slightly differently formatted data frame with states, because I asked it for all the states and the value for this variable. So the median rent in 2000 in Alabama was $334. Wow, California only $621. So I can do a bar plot of this here in line 398. Gives me a pretty nice image of median rents in 2000. You can make a little bit of a better bar plot here by lines 400 to 406. I've ordered the value in descending order in this, and I can make a really nice little bar plot here of median rents across states in 2000. All right, so finding some good census variables to use. Well, what I tend to use, because, again, the census data itself, decennial census only has a really limited sample. I would suggest help the package Tidy Census is here. I'm not sure if this links to the URL, but a quick Google of Tidy Census R will get you to this guy's, Kyle Walker's site where he built all of this stuff. There's a really long list, and what I've tried to do here is to just kind of show you how to extract and load all the variables from whichever year and whichever sample that you'd like. So if you want to get all of the 2020 ACS 5-year sample data, you can load it up using this command, which is part of the Tidy Census package. You can do this with decennial, etc. But what I would recommend, at least for starters right here, is to use the little tip and trick that I sent you with the data package here, which I'm going to navigate to under the R Bootcamp, and it's the useful census variables guide. So what we'll be using here is the variable code from the census, and saying whatever, I want tracts in Orange County, California, or I want counties in Arkansas, or I want cities in Massachusetts, what have you. So pick your variables. And pick your geographies. A lot of these are available down to the block group. Some of these are available only to the tract level. I've come up with an abbreviation. Hopefully that's a little bit useful here and intuitive. So don't worry about this section of finding good census variables. You can get started with what I've given you here. So let's assemble some good variables at the tract level, at the census tract or neighborhood level. Here on line 420, I'm using the first usage of the get ACS command, get_ACS. So I'm going to tell R to look for census tracts in the state of California, in the county of Orange. This variable, which is median rent, in that code I just showed you, I'm going to ask for it for the year 2020, and I'm going to. This argument is really fun because this will also export the shapefile alongside with the data already in it if I ask it to do geometry equals true. So it's going to take a second here, and now I have something called TR. I've called it TR in this code. So I can do a summary of TR. It doesn't have too much in the way. There's only really one field, which is the estimate, which is the median rent. Across the median rent across the tracts in Orange County, California is $2,119 in 2020, quite a bit higher than it was in 2000 across US states, certainly. I can rename, or rather make a new field called median rent, which equals estimate. This field called estimate, the way it comes is quite inconvenient, and then get rid of that previous field. So if I do summary tract right now I know I have changed this to median rent. You can see the mean is 2119. Got about 15 tracts where there's an NA, so not too bad overall. I've got one variable here. I can map it, doing this plot command, because we know how to do that from before. You can get a nice plot of median rents in Orange County if I want to do that really on the quick and dirty. Or I can go ahead and I can grab more. I can grab more variables here, and it's a little bit tedious to do it one by one. So what I can do is actually I can make a list, and I'm here in line 430. I can make a list of all the variable codes I want. If I want to grab total population, median household income, median age of housing, and this one variable that I forgot what it was, but I left it in the code, sorry. I can make a list of variables, and I'll call it, why don't I call it variable list? So what I can do then in the get ACS command is I can pass this whole list to the Census API and pull all 4 of these. So right now it's pulling all 4 of these data, these variables. So variables equals var list, which is what I called my list of variables. Now this is a little bit tedious, but if I want to see how many rows there are in my tract data set, there are 614. That's how many tracts there are in Orange County. But TR plus, which is where I grab these other variables, is 2,456. Well, what's 2,456 divided by 4? Oh, it's 614. So what it's done is it's made this long. It's just kind of stacked the data long, which is very annoying. So in order to get around that, I can subset the variables. I can do a series of subsets and match commands, and eventually, if I'll just we're a little short on time here, so I'm just going to kind of go through it. And what I'm doing here is I'm basically putting these variables I just extracted all in the same tract file. So if I do head of TR for tract, you'll see that what I've done is I now have median rent, total population, median household income, and median age of housing, age of the homes by tract. This is really cool because you can get a map of these are 60s neighborhoods, 1970s neighborhoods, what have you. And actually in line 445, this seems more interesting. So I'm gonna do this. So I'm gonna do a little plot of median home age here. And my color scale isn't super great, but it is giving me a little variation of what's older and what's newer. Now, finally, what I can do is use this st write command, which is part of that SF, and actually just export this as a shapefile straight up and use it in ArcGIS. So I'm going to write this here, and you can see. Just double check what my working directory is. It's this R bootcamp. Orange merge. Okay, I see it's only 4 here. I'm going to put it to somebody where I can grab in GIS real quickly. And if I'm here in my catalog, Tom, my colleague, is probably looking at me and is like, "Oh, you are so Bush League here using ArcMap instead of ArcPro." And orange merge. So zoom here and look at this. How convenient. I can right away make a nice little choropleth map of, let's do median rent across Orange County census tracts. Put all the bells and whistles you want in there straight from the Census API. So that's really the value of what we're able to do here, is this flow straight from the source into spatial data, or the wide range of analyses that you can do in R. So that's really the meat of it. I really apologize for going through quickly, but I'm going to leave you with one last big chunk of code here in section 8, all the variables at the tract level. What I've done here is to build a gigantic loop. If you're familiar with coding in general, you know kind of how loops work, and they're a little bit finicky in R. They rely on these braces here, the curly braces. And basically what I've done here is I've taken the variable codes for, what is this? About 100 variables or so that I use fairly frequently. And I've renamed them here into something that I find to be fairly convenient or intuitive. Again, this matches what the useful census variables is. I would recommend, if you're interested in other variables from the census, to just use this as a starting point and swap them out. Or add them to the end here. So I'm going to pick, who wants to shout out a county anywhere in the US? Not a huge one, like medium or small.
Is Alameda too big?
All right, Alameda County, California. Let's see if this works. So let's do some summarizing. Let's just say my state equals CA. So I've created a little object called my state. Let's do a little object called my county, my year, my survey. And then look at this, 461 is really the meat. I'm saying that I want tract level data. I want whatever state I put up here, whatever county I put up here. And the way I like to do it, I always like to start with total population. B0101001, my year, my survey, ACS 5-year survey in this instance. So this line here, 461, is very flexible. It's going to depend on what you put up here. So if I run these lines here together, the first thing it's going to do is it's going to give me an output, and I'm going to call it CNTY, head county, and it's going to give me just total population, estimate of total population for all the tracts in Alameda County. See how many tracts? 379 tracts in Alameda County. Sorry, Jessica, I already picked Alameda. Apologies to Santa Cruz. So what I can do here is this big, gigantic loop to get all of these variables and then to rename them. So I can run this whole thing. In fact, why don't I restart? Why don't I run all the way from 457 to 499? Select all of these and then hit Control R and then wait, I don't know, a minute, maybe. While this cranks. Less than a minute. Now I can do even some more prep work that I've done here. A lot of these are income variables. Sometimes I just want to know how many households have an income under 20,000 and over 100,000. That's an easy mnemonic. Some of these are education variables. There's a variable for every grade level, but sometimes I just want to see if people haven't graduated high school or if they have a bachelor's degree or above. There are values for every 5-year age category, but sometimes I just care about under 18 and 65 and above. So you can run these, gives you a convenient thing. And it's all in this thing called CNTY. So if I want to do the column names of CNTY, these are the columns that I now have in CNTY. And I can carefully write this to a shapefile. I'm going to call this Alameda, not Imperial. So running line 510. Okay, some field names have been abbreviated because of Esri. Okay, sorry. All right, let me grab this. What did I call this? Alameda. Apologies, I've got to switch directories here. And just to prove to you that this worked, I'm going to put this in my non-Dropbox so that I can open it up here in ArcMap, and then make a map of literally whatever I would like to make a map of in Alameda County. So across the neighborhoods of Alameda County, what is the share of population with a bachelor's degree or above? Boom, done. So I think that's all I've got here, actually, and we do have 10 minutes left. So you can do other plotting here, but this is really, I leave these 500 lines to you for your exploration and use. We have got 10 minutes left. I would like to say thanks to everybody, and let's go into breakouts so that we can chat a little bit or exchange notes if you'd like to for the last 10 minutes. I do see Jisoo, you have a question, comment, or thought.
Oh, just a quick question. What's the for represent after county on your extract all other variable line, and what part does it make the looping, like makes it loop?
Yes. Okay. So Jisoo, you mean this line here, 464?
Yes.
Okay. So when you get the data from the Census API,
Mhm.
it will always, the column name is always just going to be estimate.
Mhm.
And if I run this again and do head of CNTY, or maybe column names of CNTY, estimate is whatever variable it is. But in the way I did it, I always grab total population first. So in column names of county, item number 4, 1, 2, 3, 4, I've really sneakily renamed it total population.
Got it.
And then the looping functionality, basically here, I've got a big list of variables and I extract them here. And what the loop does is actually to rename them. And that loop is here. So for the length of this this whole big junky thing here of all of the variables, for all of the variables, I'm joining them, so it converting it from long to wide, so that I can actually see it here in a shapefile in a meaningful format.
Got it. Thank you.
Yeah. Thanks. Great question. Appreciate bringing that up. So my email's here. Send me a quick one if you'd like. I can't guarantee I'll be able to troubleshoot your issues, but hopefully this has been helpful.